In this video, we're taking a look at a very special type of laser, one that I've never tested on the channel before. This is the ComMarker COX, a Galvo-style 40-watt RF CO2 laser engraver. Just like traditional CO2 lasers, it operates in the far infrared spectrum at a wavelength of 10,600 nanometers. However, unlike standard glass tube CO2 lasers, it produces its beam by exciting CO2 gas using radio frequency. An RF metal tube is a vastly superior design. It provides much better beam quality and a significantly narrower laser spot size, which allows you to engrave incredibly fine details, a massive advantage when paired with a high-speed Galvo system. Another major benefit of an RF metal tube is its longevity. It boasts a lifespan of up to 30,000 hours, compared to just 3,000 to 5,000 hours for a standard glass tube. That incredible durability easily justifies the higher price tag. Plus, the RF tube outputs a higher beam frequency, which is exactly what you want in a Galvo configuration where engraving speeds are exceptionally fast. A wavelength of 10,600 nanometers is basically pure heat. Unlike UV lasers, which work by breaking chemical bonds, a CO2 laser works purely by heating the surface of the material. This makes it the absolute best laser type for engraving organic materials like wood and leather, or for cutting paper and fabric. While this wavelength won't work on bare metals, it absolutely excels at removing coatings from metal objects, like insulated tumblers. Now, let's dive into the tests. And if you're enjoying this video, don't forget to hit that like button and subscribe. Out of the box, the ComMarker COX comes with an autofocus sensor, all the necessary accessories, and with a generous amount of sample materials ranging from acrylic sign kit, leather tags, wooden keychains, some plywood and paper, and synthetic felt. One great perk of far infrared lasers is that the safety glasses can actually be transparent to visible light, which makes working around the machine a lot more comfortable. The included glasses feel solid and reasonably good. As for the machine itself, the laser head is enormous. It is an absolute beast. On the rear panel, you'll find standard connectors for extensions, a rotary axis, safety door interlocks, and a foot pedal. Moving to the front, you get the standard ComMarker button layout, featuring an emergency stop switch, the main power button, and manual focus height adjustment buttons. The machine also ships with two different lenses, a 140mm lens for finer details and more demanding materials, and a 210mm lens for a larger work area, which is perfect for sizable wooden boards and tumblers. To see how this laser performs, I started by running some test grids to check different power and frequency settings. I engraved several patterns, and the results were incredibly consistent. Here is the test pattern where I varied power and frequency. And here is the grid varying speed and power. As you can see, the engraving effect doesn't change drastically across different settings. This is a huge plus because this type of laser isn't nearly as sensitive or finicky as a fiber laser. To put it simply, you're either burning the material or you aren't. At least that was the case on the wood I tested. This means you won't have to spend hours fine-tuning parameters for every single material. I ran the exact same test patterns on transparent and black acrylic and got identical results. The frequency didn't matter much, and almost all the markings came out clean. Another benefit is that this laser is entirely unaffected by the color of the material, unlike diode or fiber lasers. Engraving on faux leather yielded similar behavior. Once you push past the minimum power threshold required to mark the surface, everything looks great. I really appreciate this predictability because with other laser types, finding the sweet spot usually requires a ton of trial and error. Next, I wanted to test the usable focus range of this machine. I engraved a line of text across a piece of plywood which was set at an angle, focusing the laser directly on the top of this metal block. The results show that the 210mm lens has a very forgiving focus range, spanning a few millimeters both above and below the optimal focal point. This is much better than what I've experienced with fiber and UV lasers, meaning small curves or uneven surfaces won't ruin your engraving. To measure the actual laser spot size, I engraved a piece of anodized aluminum using various interval settings. By their very nature, CO2 lasers have a larger spot size due to their longer wavelength, so let's look at the results under a microscope. Starting with the 140mm lens, I was amazed to find that the spot size was actually smaller than I anticipated, coming in around 0.12 millimeters, which is incredible for a CO2 laser. Looking at the microtext, the 0.6mm font is perfectly visible. However, that was engraved at a relatively slow speed and clearly used a bit too much power. When bumped up to 1000 millimeters per second, the results are much sharper. The text retains excellent shape, and even the tiny 0.3mm text is still readable. To give you some perspective on this level of detail, here it is compared to the tip of a graphite pencil. At 3000 millimeters per second, we start to see the physical limitations of the Galvo system, but you wouldn't typically use speeds that high for line engraving anyway. That's reserved for fill patterns. Switching to the 210mm lens, the laser spot size expands to approximately 0.22 millimeters in diameter. That's still a great result, considering this larger lens is meant for scaling up your designs. Looking at the text, the 0.6mm font is still clearly visible, while the 0.4mm text is right on the limit of readability. At 1000 millimeters per second, my power setting was a bit too low, making the engraving look a little faint. While a spot size of 0.12 to 0.22 millimeters is very small for an RF CO2 laser, it is still considerably larger than a fiber or UV laser. But that isn't necessarily a bad thing. It can still engrave incredibly fine text, but because the spot is slightly wider, you can use a larger interval setting for your fills. This means an RF laser can fill shapes at lightning-fast speeds. To demonstrate this, I set up a test at 3000 millimeters per second at full power, using a wide 0.2 millimeter interval on the larger 210 millimeter lens. Look at how fast this machine clears the area. This incredible speed is a massive time saver, allowing you to breeze through high-volume production runs and maximize your profits on large orders. Next, I wanted to engrave a photo to see how much detail the COX could preserve. Using the ComMarker Studio software, I selected a preset for plywood and let it run. The engraving speed is absolutely mind-blowing, and the final image looks fantastic for its size. It burned quite deep into the wood, creating a really nice tactile effect that I love. Moving on to a denser wood, I grabbed one of the wooden keychains included in the sample pack. The engraving finished in just a couple of seconds and left a beautiful, high-contrast mark. I decided to flip the keychain over and run 10 passes using the exact same settings to see if I could get more depth. The result was even better than I expected. The contrast improved, and it achieved a depth of around 2 millimeters, which is incredible for such a short runtime. This tells me you could easily use this machine for 3D relief carvings. Of course, there are some materials that a CO2 laser simply cannot handle. For example, this plastic cosmetic jar lid, which can easily be marked by UV and fiber lasers, does not fare well under a CO2 beam. Because the CO2 wavelength just melts the surface, it leaves behind a distorted, melted mark with zero contrast. It's truly amazing how differently these laser wavelengths behave on the exact same material. On the flip side, the COX did an excellent job on this polyester sports towel. It perfectly melted away the fine top fibers to expose the fabric underneath. The finished graphic looks great, and the ComMarker COX completed it much faster than a UV laser could. Next, I tested the machine on some river stones. Because the far infrared beam acts as pure heat, it creates microfractures on the stone's surface, changing its color. I tested a few different stone types, some engraved beautifully, while others were less impressive. Overall, performance was similar to a fiber laser, with the exception that the CO2 laser can't achieve deep structural engraving on stone. But where the ComMarker COX wins is pure speed. It can engrave large slate coasters in the blink of an eye. The final look is very clean, with great detail and sharp clarity. Out of curiosity, I wanted to see if running multiple passes would add depth to the stone. I let it run at maximum power. first at a slow speed and then at a faster speed. Interestingly, it didn't cut deeper at all. Instead, it actually melted the stone's surface, turning it into smooth, durable glass beads. While it wasn't what I originally expected, it's a really interesting effect that could definitely find a unique application. I also tested a ceramic cup. For comparison, the top engraving here was done by a fiber laser, and the second was done by a UV laser, which looked much better. So, how does the CO2 stack up? Once again, the ComMarker COX flew through the design with incredible speed, and the final result looks just as sharp and clean as the UV laser. I honestly wasn't expecting it to turn out this well, and I'm thoroughly impressed. Then, I tried my hand at wine glasses. Glass absorbs far infrared light incredibly well. The laser heats the surface, creating micro cracks that give it a frosted look. On my first attempt, it generated a fair amount of glass dust and left some sharp, jagged edges that I wasn't happy with. I repeated the test with lower power, which yielded a much cleaner result. A light rub with some steel wool can clean up the surface very well. This proves you can absolutely engrave glassware with a CO2 laser, though the results won't be quite as pristine or hyper-detailed as what you'd get from a specialized UV laser. But one of the absolute coolest things you can engrave with a CO2 laser has to be insulated tumblers. Because the beam completely ignores the stainless steel underneath, the process isn't sensitive to your settings at all. You just need enough power to strip the coating away. Up until this point, I did the majority of my testing using Lightburn software. However, for setting up the ComMarker rotary axis, I switched over to ComMarker Studio because the configuration process is much simpler there. During the engraving process, the design might look dark, charred, and messy. But don't worry. After it finishes, you just give it a quick wipe with a sponge and some dish soap, and the underlying steel shines through perfectly. Without a doubt, using this machine is the simplest and fastest way to engrave tumblers out of any laser I have tested so far. In addition to engraving, a CO2 laser can also tackle some cutting tasks. You can use it to rapidly cut paper or fabric to create custom stencils and intricate artwork. I tested its cutting ability on the synthetic felt included in the package. By using a high speed and running a few quick passes to prevent the material from melting together, it produced a remarkably clean edge. Finally, CO2 lasers are renowned for handling leather at breakneck speeds. I tested it on this piece of genuine leather, and the result is spectacular. The engraving is incredibly fast and leaves behind a rich, deep contrast. Next, I was curious to see how well a CO2 Galvo laser could cut through 5 mm thick acrylic using the 210 mm lens. I ran 20 passes at full power and a relatively slow speed, and it sliced right through surprisingly fast. The parts dropped out effortlessly and looked fantastic. However, taking a closer look, you can see that the edges are cut at a slight draft angle. This is completely expected with a Galvo system due to how the mirror angles the beam, but the cut quality itself is extremely smooth, making the finished parts highly usable. Finally, I wanted to test acrylic engraving one last time. But to make it a bit more fun, I decided to build a custom illuminated sign using the display kit included with the machine. The COX engraved the acrylic in no time, producing a razor-sharp design with striking contrast. But once I mounted it into the light base and turned it on, I was completely blown away by how good it looked. Overall, the ComMarker COX 40W CO2 Galvo is an absolute workhorse, blending the material compatibility of a CO2 laser with the blistering speed of a Galvo system. It really changes the game for high-volume projects.